This is Northern Oklahoma College Algebra, Math 1513, Chapter 1.3. I'm working an example for your homework problem number 11. Remember, we're doing quadratic equations. These we're going to solve not by factoring and the zero product principle. Instead, we're going to solve by using the square root procedure, which is pretty much what it sounds like. You're going to have something going on, and you're going to take the square root of both sides. That's what's getting ready to happen. So we start with x squared equals 225. And like I said, you can solve quadratic equations several ways. What we're learning here is the square root procedure. So that's what you need to use on these. You see that square there? I'm going to square root both sides. Now this works very nicely because that x squared is by itself on the left side of the equal sign. And lots of times that's your clue. When you see x squared alone on one side of the equal sign, you're probably going to do a square root procedure. You can use any method you want, but that's probably the easiest. So we square root both sides. Now remember, when you square root something, for example, if I say 3 squared, well, everybody knows that's 9, right? Now if I take the square root of that, remember square roots, they have a little 2 here. We just never write it. We're too lazy. We use square roots so often we don't put the 2 there. So if I square 3 and then take the square root, what do I end up with? Well, 3 squared is 9, and the square root of 9 is right back to 3. So that means this square root and that squared power there, that raising to the power of 2, cancel each other out, leaving just my 3. That means square roots and squares cancel each other out. All right, so we're going to use that idea up here. I have the square root of x squared. Well, those cancel each other out, leaving just your x. Square root of 225, you can use your calculator, or you can think, what number times itself gives me 225? It's going to be 15. Think you're done? Not quite. Okay, turns out we were half right with the x equals 15. Let's back up and talk about square roots again. The square root of a number, for example 9, when I say square root, I'm saying what two numbers, remember that root's a 2, so what I'm asking for is what two numbers, what number, when I use it twice and multiply, gives me 9. So I'm thinking, what two numbers, it's going to be the same number, multiplied together give me 9. Well, that would be 3 times itself, 3. Therefore, we say the square root of 9 would be the number 3. But there's another way to get 9 using two of the same numbers, and that could be negative 3 times negative 3. So I could say the square root of 9 is 3, but it's also negative 3. Now here's a short way of writing this that lots of mathematicians like to use. They like to put a little plus or minus sign in front of the 3 to mean both positive and negative 3. So I'm going to work this problem again the correct way. So I see x squared. I'm going to cancel that out by taking the square root. I have to do it to both sides. Let's take the square root of both sides. Square root and square cancel each other out. So I have x equals, now it was 15, but remember it's 15 or negative 15. That's a long way of writing your answer. A shorter way of writing the same thing could be like this with a comma separating them. That's just fine. Probably the shortest way of writing the answer is putting your 15 with the plus or minus sign. And that's what I usually do. That's the easiest. All right, before we go into example for number 13, I want to talk to you guys about square roots. Now, remember every number has a square root, okay? Square root of 1 is 1. Square root of 2 is 1.4142. Square root of 3 is 1.7321. Square root of 4 is 2, and so on. Every number has a square root. It's just that some of them are not pretty. Okay? We like the pretty ones, and we call the pretty ones perfect squares. We like the perfect squares because their roots turn out to be whole numbers. And we like whole numbers. Whole numbers are easy to deal with. We do not want to mess with these guys because their roots are, you know, messy, nasty, infinite numbers. So what I'd like you guys to do, and I'd like you guys to put these on your notes for your test, is make a list of all the perfect squares, or at least the first 10 perfect squares. Sometimes it's easier if you think about what the answer is going to be. If the answer is going to be 3, I must be talking about 3 times 3 or 9. So the square root of 9 must be 3. If I think about 4, well, the square root of 16 would be 4 because 4 times 4 is 16, and so on. So it's handy to keep a list of these numbers that are perfect squares, the ones whose square roots reduce down to whole numbers. Another note you might make is that we hardly ever use the square root of 1 equals 1. It just really doesn't help us simplify anything. So if you will keep a list of the other perfect square roots, we'll use those a lot. So let's look at this example, y squared equals 48. Remember, the whole idea is to get y alone, to isolate y. So I need to get rid of that square. How do I get rid of square? I do the opposite. I take the square root. You can put the little 2 in there if you want to. So I take the square root of both sides. Square root cancels square, leaving just my y. And now we have a square root of 48 to simplify. Now that's a very large square root. What I want to do is I want to simplify that into a perfect square times whatever's left over. Alright, so I'm trying to break 48 into a perfect square times, whatever's left over. So I think of all the numbers here that will multiply to give me 48. And I'm looking for those perfect squares. Use that list we just made. I see 1 is a perfect square, but it never helps us simplify, so I'm not going to look at it. I see that 16 is one of my perfect squares, because square root of 16 is 4. And I see that 4 is a perfect square, because square root of 4 is 2. None of the others are perfect squares, so I'm not going to look at them. So I'm only looking at 16 or 4. I'm going to use the bigger number, 16, because it'll just help me simplify it faster. So I'm going to put 16 in here in my first square root bracket. And the 3, it was 16 times 3. That's kind of my leftover. I'll put my leftover 3 over there. So all I did was change square root of 48 to square root of 16 times square root of 3. That's totally okay to do. Why did we do that? Because that square root of 16 is going to turn into a whole number 4. Square root of 16 is just 4. The square root of 3 comes down, and I've simplified it. So y equals 4 square root of 3. Now remember what we talked about a while ago. Anytime you take a square root of anything, you're going to have 2 answers. So what I want you guys to start doing is anytime you take a square root or put a square root bracket in front of anything, I want you to start putting plus or minus in front of it to remind yourself that you have 2 answers. So you are done right here, but if you want to be more specific, you can split it into 2 separate answers. So you could write it like this way if you wanted, but I like the first way, it's shorter. Just put that little plus or minus in front every time you take a square root. Alright, before we start example 15, we need to talk about the square root of negative numbers. Okay, the square root of negative numbers, if you punch this into your calculator, square root of negative 100, you're going to get an error. Alright, this is what's called an imaginary number. We don't really know what it is. It's the square root of a negative number. It doesn't really exist. So this kind of creates a logjam in solving the problem. We need to know how to deal with the square root of a negative number. So what we came up with is we define the square root of a negative 1 as the letter I for imaginary, okay? It's not real, it's imaginary, it doesn't exist. So if I had something like square root of negative 100, which stops my problem, and creates a stopping point where I can't go any further, in order to finish the problem, I'm going to rewrite my square root of negative 100 is the square root of negative 1 times the square root of 100. I can call the square root of negative 1, this part right here, I can just call it I for imaginary. That's our symbol for square root of negative 1. Times, remember, anytime 2 radicals are next to each other, you're multiplying. And the square root of 100 is 10. And don't forget, anytime we take the square root of anything, we have a plus or minus sign in front of our answer. So my final answer would be plus or minus, and it's I times 10, but a better way to write it is the real number first, and then times the imaginary number. Or an even shorter way is plus or minus 10i. That's what we're getting ready to deal with. So if you see something like this, you see a negative and you're getting ready to take a square root, you know that we're going to deal with i's and imaginary numbers. So remember, we want to get our x alone. That means I have to get rid of that little squared up there. How do you get rid of a square? You square root it. They're opposites, they're inverses, they undo each other. Don't forget to do it to both sides. So remember, the square root cancels the square, leaving just your x. And on the right side, don't forget, squeeze in a little plus or minus. Every time you take a square root, remember it's got two answers, a positive and a negative answer. So I want to work on this a little bit. There's my plus or minus, and I'm going to pull that negative sign out because we can't take the square root of a negative. So I'm going to pull out a -1 and rewrite -121 as -1 times a positive 121, just to get that square root of -1 out of the picture. Remember, we call square root of -1 an I for imaginary, and it's being multiplied times the square root of 121, which turns out to be a nice whole number 11. And finish off the problem by just writing it simpler as plus or minus 11i. Now there's your answer. Just remember it means 11i or negative 11i. You have two answers. All right, this one's a little trickier. Remember, we're going to square root something that's being squared. That's what's getting ready to happen. So this 64 is actually in the way. We need to move it first. And by subtracting 64 from both sides, now I have x plus 1 all squared equals -64. Now I'm ready to get rid of that square. How do you get rid of a square? You square root. You can put the little 2 there if you want to. Square root both sides. Don't forget, anytime you take a square root, squeeze a plus or minus in there. I didn't leave very much room. Square root cancels square. And now we have x plus 1 equals plus or minus the square root of -64. Now you guys know how to deal with the square root of a negative number now. I split it into square root of -1 times square root of 64 and get plus or minus 8i, because square root of 64 is 8, square root of -1 is I. Now I'm almost done. I got to get that x alone. I minus 1 from both sides and get x equals, now it looks like plus or minus 8i minus 1, which is technically correct. So x equals plus or minus 8i minus 1 is technically correct, and that's an okay answer, and you can circle it if you want to. But to be, let's call it grammatically correct, you need to put the real number first. And your 8i, with that I right there, that's your imaginary number, your imaginary term. And the 1 is your real number. So it's better grammar, better mathematical grammar, to put the real part first. So I have -1 plus or minus 8i. Remember, that 1 was negative. It had a minus in front of it up there on top. And when you move it to the front, that's fine, but take that negative with it. That 1 is always negative, and the 8i is always plus or minus. Okay, and finally, they're just going to give you a problem where the square root doesn't always turn out to be one of those nice, pretty square roots. So remember your strategy here. We're using the square root principle. That means we want something squared, and then we want to take the square root of both sides. That's what's coming. So we need to get the square alone. We need to get rid of that 5. And I need to mention I copied that number down wrong. That's actually a 37. It's not a 32. Turns into a 32 when I subtract 5 from both sides. So now I have y plus 2 squared equals 32. And I take the square root of both sides. Remember, a square root cancels a square. And now I have y plus 2 all by itself. That's the square root procedure. And don't forget, anytime you take a square root, squeeze a little plus or minus in front of it. And here's what I have. Y plus 2 equals plus or minus square root of 32. Now that square root of 32 will simplify further. We can do it right now, or we can do it at the end of the problem. I'm going to go ahead and isolate that y, so I'm going to go ahead and get rid of that 2. And I have y equals plus or minus square root of 32 minus 2. We still need to simplify that big square root. So I'm going to break it into a perfect square times whatever's left over. So I notice that 32 can be broken into the perfect square 16 times the leftover 2. And I simplify square root of 16 to a whole number 4. So I have 4 square root of 2, or 4 radical 2, you can say it either way, minus 2, which is technically the answer. But again, we like the real whole number first, and anything weird later, like imaginary numbers and square roots. And here's our final answer. Now I messed up a little bit on purpose, trying to see if you can spot it. Remember, I moved that 2 to the front. All right, that 2 was a minus 2, which is the same thing as negative 2. So when I move it up here, it's fine as long as I take that negative with it. And there's our final answer.